Okay, here's an example again for a test of a population mean. Now, this is a t-test, and the reason that we're using the t-test is that if you read through the scenario, they do not give us the population standard deviation. And I addressed that issue in the big idea video, so get more in detail. I'm just going to give you the facts here, and that is why we use the t-test. No population standard deviation given. If you want to little more extensive explanation why I addressed that in the big idea video. So now we have this, I guess, this organization here that talks about the mean height of begonias, and I believe that's a flower. And they're trying to enhance, I guess, the height of the growth here. And so what we're doing here is, again, looking at some sort of effect on, changing it to, perform better in terms of the plant world. And, the bottom line, I'm going to cheat here again is that I'm going to use the solve button here so you don't have to painfully watch me type all that stuff in. Okay. So now we have here that they tell us that it's the mean height is 40, and to detect whether this is still accurate, heights are measured. We've got another sample of 10 here, and we find that the sample standard deviation of those heights is 36, okay? And the magic button here, notice some of the other examples. This is our first two-sided test here, and it says, assume these are normally distributed, and all that means is this situation or the conditions exist for us to use the t-test, but can it be concluded the population is different? Okay, so this is the key word here, different. It would have said maybe less than or greater than, then obviously we would put those symbols in here. But since it says different or differs, then we use the not equal sign, okay, for that particular value of 40, which they gave us. Again, I address why we're using the t-test because we don't know the population standard deviation. And so, looking at all the other given information, and the idea is, okay, well, where's all this other stuff come from to run this t-test? Well, we're going to go back to your master sheet here, and we're going to look at the t-template for one sample, okay? And when you're looking at these, we already used the confidence interval in week 4. And so now we're going to do the significance test or hypothesis test. Those are interchangeable terms, and just enter in, again, the red numbers as always. So we're going to put in the values here. Let me scroll down. So 40 was our given hypothesized value. And we have a sample size of 10. So I'm just reading down through the paragraph here. We have a sample standard deviation. The mean is 36 and the standard deviation is 7, and that's our sample values. Okay, so I'm going to put in for X bar then the 36. All right, so type that in here. And then I am going to put in for the standard deviation, which was 7. Okay, so I think I got everything in here, and the significance level is 0.05, so that's already in there. So here's where all those numbers are coming from. Okay, first thing is we go ahead and get the test statistic. All right, I do give you the formulas here if we wanted to take a quick look. They're given in a generic form. So to get the t statistic, we take a look at our estimate, which is X bar, plug in here, and notice, again, when we have an unknown population standard deviation, the parameter, again, is always going to be mu here when dealing with means. And then our spread or standard deviation is S divided by the square root of n. So that would go in here. Now, if we knew sigma, like I said, that's a Z statistic. Okay. But we don't really need that here. It calculates all that for us. It does the X bar minus the 40 divided by 7 over the square root of n. And that's what that number is. Then it's also going to give us the p-value for the two-tailed test, which is 0.104. Okay, and you can see that. So, if I did go to just illustrate you visually what's going on, we want to calculate the area underneath the curve. And by the way, also, notice it does give you the degrees of freedom of 9. And it's usually easy to remember here. It's just one less than the sample size, but they go ahead and report it here for you. And so it does give you, all the right tail and left tail values based on that particular T statistic. We're interested in the two-tailed one, like I said, for the p-value here. So we just type that in. And by the way, we do not have enough evidence, right? Because that p-value is greater than the alpha. Okay, so that does the problem here. This is just a little bit extra, to show you what you have here for 9 degrees of freedom. So if I plot that distribution and I want to calculate the area, okay, and outside a region, okay, so what I have to do is I have to type in this left boundary. So that was the reason I type in that for the left. That is the actual value of the test statistic, 1.807. And what we're going to get is this p-value of 0.104 here when we're done. But remember, this is a symmetric distribution. And since it's a two-sided test, we also have to find the area not only to the left of 1.807, forgot my decimal point here, but we also have to find the area to the right of 1.807. Now, again, you don't have to worry about this in the the Excel sheet, okay? But you can see that we're getting 0.104 here. They're just expressing it as a percentage. So that just, again, shows you what we have here, okay? So, the left tail is 0.521. Add those together, you're going to get your 0.104, okay? So there you have it. That is the t-test. There's other types of t-test questions on there, but they're very similar to this, and that's the main idea.